Hi everybody, welcome back. We're now on 3.1. We're still investigating quadratic functions in vertex form, but now we're on part 2, equations of quadratic functions, and we're going to do some word problems. So in example 1, as you see here, it says determine the number of x-intercepts for each quadratic function by using the vertex and just the direction of the opening. So in a sketch, we're not going to graph these. I'm going to graph them when we're done, but just we're going to determine what the graph looks like just based on the vertex and how it opens. So the vertex here would be negative, would be negative 7 and negative 5. It would open upward or downward. It would open upward because your a value is positive. So remember, if the function at the very beginning is positive, it opens upward. If it's negative, it's downward. All right. The equation, obviously, if the vertex is in here, this would mean it would be in quadrant 3. It opens upward, so it would have 2 intercepts. So I want you to sketch the graph here. I'm going to do a quick sketch in Desmos. So I'm going to copy my equation. All right, so now I'm going to cheat. I'm going to copy this graph. I'm going to put it into our Desmos graphing calculator. You'll notice that, okay, there we go. And all we want to know is that there's our vertex. Doesn't matter what the points are, but you can clearly see that there are 2 x-intercepts. So I'm going to copy this, and I'm going to put it into our little graph here. It's going to be huge, but I can just make this smaller. Boom. There we go. So you would just sketch that. You don't need anywhere near that. All you need is a vertex. Clearly show that there's 2 x-intercepts, because that's the idea of this exercise, is to determine how many x-intercepts there are. And you could have found out, knew there was 2 based on the vertex being in quadrant 3, and an opening upward would obviously result in 2 x-intercepts. So if you say 2 x-intercepts, so we have 2 x-intercepts. Or you can put 2 if you want. The next one, we're going to have our vertex. Vertex, this one's an interesting one because your vertex is 2, 0. There's nothing added to this, so that means you're adding q, and q is 0. So we have a plus 0 here. So that means the vertex is at 2 and 0. Tell me something about 2 and 0. 2 and 0 is directly located on the x-axis. All right? Again, like the previous, it opens upward. All right. So you want to predict how many x-intercepts there are. So I'm going to copy that. I'll let you think about it for a minute. As I graph the equation, I'm going to copy. I'm going to bring that to my graph. I'm going to get rid of my previous. Copy my graph. And you'll notice that it is literally touching. And I think we talked about this in Math 11. So this just comes down and it's a touch or a double root. So that's why you know this equation. If you were to expand that, it would be x minus 2 squared. And there's your graph. Right? Same thing. Pretty neat. So what we had before, it's the same thing. They just overlap because it's just expanded. That's why it's considered double root. And we could call that a touch. All right. So I'll copy that, paste that. Hopefully you would have came up with that information on the sketch on your own. So that's considered, even though it's double root, we consider that 1 x-intercept. And I'll make the graph super small. And there's your sketch. Put it in the middle. There you go. And then the last one, we have the vertex is located at -1 and -4. So again, we're in quadrant 3 again. but this time it's opening downward. So if we're in quadrant 3 and it opens downward, sorry, I got to put 1 here, 1 x-intercept in that previous example. So how many x-interceptors are going to be here? Make your prediction. So I want you to think about it. You guys are thinking as I'm going to take and graph it. So I'll bring the graph up. I'm going to get rid of the last equation. I'll put the new one in. And if you said there are no x-intercepts, you would be correct. The vertex is here at -4 and 1. It opens downward. So if it's in quadrant 3 or 4, mind you, and it opens downward, you get a graph that looks like this. And I'll fix that up for you in a minute. There we go. Toward the middle. And there are your 3 equations and your 3 possibilities. You can either end up with 2, 1, or no x-intercepts. Perfect. So there's just a summary at the bottom. So the values of, and here we're putting the P and Q. So the P and Q is just your vertex values. So if you have the values P, Q, and you know A, this will help you determine whether a parabola has 2 2, 1, or 0. Cheating. Sorry. 2, 1, or 0 x-intercepts. Or you could say 2, 1, or no. I'm going to use the word no instead of no x-intercepts. So that's just a summary of the investigation. Just taking a look at prediction. We're looking at a graph predicting how many intercepts it will have based on vertex and direction of opening. So your PQ, which is your vertex value, PQ, and your A value will help you determine it. So let's look at example 2. We have 2 equations here, and then they want us to determine the equation. So remember, what you need to do is you need to have the vertex, which we know because it's in vertex form. So we know the vertex here is at negative. You can see that clearly the vertex is at so you get the vertex at -3 and 1. Okay. And I know another point. You want to know another point on the graph. I'll pick the y-intercept. You can see right here, it's clearly going through at 0 and 7. So we have another point, 0 and 7. So that gives us an x and y value. That gives us the PQ. Now we can solve for A. I know we did this earlier in the review section. Just want to make sure we got a handle on it. So remember, f of x is also y, right? It is equivalent. So put our y in. Y is 7. It's going to be 7 here. Our A value is what we're looking for. X is going to be 0 right here. P is equal to -3. So negative, it ends up being +3. And our Q value is 1. So put a 1 in. And then we're going to solve. So I'm just going to recopy that. Maybe I like to leave my equation there and showing where I filled everything in. So I'm just going to put that back in. Should have copied it again. I do apologize. And then we'll solve. We'll bring the 1 over now. This, if you want, take that over now. So 7 subtract 1 from both sides, you get 6. That'll get rid of the 1 on the end there. And I could square the 3. 0 plus 3 is 3. It's going to be 3 squared, which would equal 9a, right? 3 squared is 9. You end up with 9a, and then you divide. Your final step would be to divide So divide both sides by 9, and we get A is equal to 6/9. Okay. So now we're going to fill everything back in. So we take the original equation, we plug in everything other than x and y. So right here at the front, we're going to put in. Sorry, I like the fraction. So I'm going to insert fraction. So that's going to be 6/9, which can be simplified to 2/3, right? 6/9 can be simplified to 2/3. So I like to use the simplified answer there. So copy. So A is actually equal to 2/3 when it's simplified, right? Plug it in. Our p-value, remember, was -3. Minus minus ends up being +3. And our q value was +1. So here, what you see in the shaded is the equation. And again, if we want to put in the function form, we'll put f of x back in there, right? So there's your answer there. It's f of x equals 2/3 x plus 3 all squared plus 1. Remember, the x value, the a value would be 2/3 because it opens upward. Be mindful of that. We'll do the same thing again with the second graph. So this time I don't need to write the vertex. I can just start plugging stuff in. You guys get the handle of this now. So plug our values in. Our vertex is clearly 3 and 2. So this will be 3. This will be 3. Our q value is 2. X and y, pick any other point. These go through clearly right here. 2 and 1 or 4 and 1. It doesn't matter. I'll pick 2 and a y value of 1. So I pick this point right here, 2 and 1, and then I can just solve. So copy. And I'm going to add subtract the 2 from both sides, so that'll make that a -1. 2 minus 3 would be -1 squared. 2 is gone because I have already subtracted from both sides. Now I'm going to square the -1, which is just going to give me 1, right? -1 squared is 1. 1 times a is a. So a is simply -1. Then I rewrite my equation. And now is where I'm going to substitute all the values in except for x and y because they're part of our equation, obviously. So the p value was 3. Our q value was 2. So the final equation, and we can put this in. If you want to do a function f of x equals, I shouldn't have 2 equal signs there, my apologies. I'll underline it, I'll italicize that. There's your equation. And you can just put negative. You can put -1 or you just put negative like that. It's the same thing. I'll put 1 in just for now. Right? And there's your 2 equations. So that's how to find the equation from a graph. That's it for example 1 and 2 on pages 9 and 10. In the next video, we'll finish up the chapter with 2 examples of word problems. Hope you enjoyed the video, and we'll see you again soon.